What's poppin', dogs? Mr. Allen here. We got some operations with imaginary numbers in this video. Love me some imaginary numbers. Let's go to the top right here. We have 2 times the quantity 3 minus I minus 4 plus 6I. Well, here's the whole dealio with imaginary numbers. You can basically work with them as if they were x's, y's, any other variable. The key thing is, though, that when you have I squared, it becomes a -1, okay? Since the square root of -1 equals I, if I were to square that I and square the other side, my I squared is going to equal, well, squared square root, that cancels -1. And then you can go to I cubed and I to the 4th. I'm going to do that in another video. We worked with some different stuff, okay? For now, we're just going to do some simplification. So over here, I'm going to distribute the 2, as I normally would with any other variables. I'll have 2 times 3 is 6, and then 2 times -I is -2I. And over here, you can think of this as like a -1 right there, right? I got to distribute that negative or the -1 into the parentheses. And now I have -4, and we have -6I. Lovely. Now I just combine like terms. 6 minus 4 is +2. -2I, -6I is -8I, and that is our final answer. You are going to write it in the form, I'll write this down right now, A plus BI, okay? That's the complex number form where A and B are just normal real numbers, right? But this is a real number and an imaginary number with a coefficient that's real, all right? So that together makes a complex number. Anywho, basic operations, algebra 2 type stuff. You get into the more crazy imaginary numbers and complex numbers in future math. For now, just getting the basics down. All right, down here. What do we do here, right? A lot of times people are like, oh, should I just put that together and that's 3? No. This is multiplication right here. Multiplication comes first. So I'm going to distribute my -3. This 6 remains as a 6. Then I have -3 times 2 is -6. -3 times 4i is -12i. And then that -I just chills and stays -I. Now I have 6 minus 6 is 0. And we have -12i minus 1i, that's -13i. So sometimes one of the things goes away. You're just left with -13i or 5, right? You can just be left with one number. It isn't always like this. In this case, a is just 0, right? And then b would be the -13 for that a plus bi form. All right, let's do some orange marker now. We got 2 binomials multiplied together, essentially, right? So I'm going to do 3 times 5. I'm thinking like FOIL or distribute here, whichever term you like to use. FOIL is more like street math, okay? Whereas distribution is more universal and is associated with multiplication, okay? But FOIL, first, outer, inner, last, that's street math term. It's not formal. It's not a formal math term, but it does get the job done. So then I've got 3 times I is plus 3I. -2i times 5 is -10i. And then we have -2i times I, that's -2i to the first times I to the first is I squared. We have our first encounter with I squared. So what I like to do here is I'm going to say that this is -2 times -1, which is +2. So let's rewrite this now. I have 15 plus 3i, I'll wait to combine all my like terms, minus 10i, and then we have -2, -1, that's +2. All right, you could have combined these right away, but I'm just going to do all that in one step right now. I have 15 plus 2, that is 17, and then 3i minus 10 is -7i. We are in the form A plus BI. That's dope. All right, last one here. A lot of people think, oh, I'll just distribute the exponent of 2 into my 2 terms here. No, absolutely not. Not cool, bro. Not at all. You cannot distribute an exponent into a sum or difference, okay? You could do it if it's just one term, okay, and it's all multiplication in there. But if there's any addition or subtraction, you cannot do that. You have to write it twice or think about it being written twice. I usually like to do this. I just get rid of that guy, and I write 3 plus 4i all over again. And now I think about it as distribution, just like that one, right? I took a problem that I wasn't sure I know how to do, change it into one I just did, and now I can do the math. So I got 3 times 3, that's 9. 3 times 4i, that's +12i. 4i times 3 is +12i. And then 4i times 4i is 16i squared. Oh boy, we've got our -1 again. So this is the same as 16 times -1, which is going to be -16. So let's write that up. 9 plus 12i plus 12i minus 16. And if you're feeling a little more comfortable with it, once you see this, you'd be like, oh, I'm just going to combine those and I'm going to finish this problem. That's totally cool. I'm writing out a few more steps just in case you're still having trouble with it. I want to show all that work like Rihanna. Anywho, 9, -16, that is -7. And then 12i plus 12i is positive 24i. We are in the form A plus BI. We just did 4 dope imaginary / complex number problems here. Those do mean different things, but they're often interchanged terminology early on. All right, this is a complex number, which is made up of real and imaginary. All right, that's the difference there. At least I think it's the difference. If I'm wrong on that, somebody correct me. Pop it in the comments. Be like, bro, you're wrong. But I think I'm right. Anyways, hope that helps you guys. I'm going to do some other videos on imaginary numbers as well, so be sure to check those out. Like, subscribe, tell people what's up, and have a great day.